nuclear power station is a factory which produces electricity. Factories have an impact on their surroundings, notably by their release of waste products into the environment. Unlike most factories, a nuclear power station contains radioactive fuel. This means that safety is the key factor in its design, construction and operation. The protection of man and his environment is the chief aim of nuclear safety. To achieve this, the basic objectives are to construct the nuclear station to the highest design standards, to ensure its correct operation, to prevent accidents and to limit their effects. This program covers the design aspects of nuclear safety. The pressurized water reactors at Daya Bay Power Station are being built to a French design, which has a 20-year history of reliability and safety. In the reactor core, safety depends upon three basic functions. First, energy production is controlled by limiting the number of fissions in the uranium fuel. This is achieved by the use of neutron-absorbing control rods, or by adding another effective neutron absorber, boric acid, to the pressurized water coolant. Secondly, the heat produced in the core is continuously removed by the pressurized water flowing through the primary circuit. Finally, radioactivity is confined because the steam to drive the turbines is generated in a totally sealed secondary circuit, isolated from the primary. To prevent the release of radioactive emissions to the environment, three barriers exist. First, there is the sealed metal cladding around the uranium fuel which prevents fission products from escaping into the surrounding water coolant. Second, the reactor core and fuel rods are housed in a steel pressure vessel which is part of the totally sealed primary circuit. The third barrier is the containment building of steel and thick reinforced concrete, which surrounds the entire primary circuit and provides resistance to external and internal stresses. At Daya Bay, safety design features are based upon defense in depth. These are a number of successive lines of defense and backup systems which protect against human and mechanical errors. For example, in the case of a loss of coolant in the reactor, borated water will be injected. One pump is sufficient to do this, but three are provided. This so-called redundancy factor, providing more units of the same kind than are needed, ensures that safe performance is not dependent on a single part. Should reactor shutdown be necessary, this can be achieved either by lowering the control rods into the core or by injecting boric acid into the water coolant. So, different methods exist to perform one safety function. If a system fails, one or more alternatives are immediately and automatically available. The reactor's control rods are held out of the core by electromagnets. If power fails, the rods will drop automatically by gravity in less than 2 seconds, stopping the fission process and so shutting down the reactor. This is the fail-safe factor. Another factor is to keep apart any parts or systems which are doing the same job. For instance, if a pump has 2 backup pumps, they are at different locations so that fire or flood cannot affect them all. In the same way, electrical circuits follow different routes. The overall technical supervision at Guangdong Nuclear Power Station is provided by Électricité de France, which has a proven track record in the design, construction and operation of nuclear power stations. Their responsibility in the management of the project ensures that Daya Bay Power Station fully complies with French construction and operational requirements.